I work at IBM Almaden Research Center, and just realized we are also hiring. So if you're interested, people we're looking for are in text mining, data mining, looking for people who are interested in services research, which is the area I work with, which is looking at applying these problems to real customer engagements, looking for ways to improve service efficiency. Almaden is a great place to work. We're located down near Bernal, out in the park. I remember 14 years ago when I first interviewed there, I think more than the job they offered, I fell in love with the building. It was just an incredible place. It was built in the early 70s, and it's everyone there has their own office with a view, and just really nice kind of atmosphere. And it's a great place in terms of the people who work there. We have physicists, we have material scientists, mathematicians, computer scientists, service researchers, ethnographers, just an incredible mixture of talent in all different areas of expertise. So it's a constant place where you can get exposed to new ideas, new ways of thinking, new areas. So with that plug, I'll move on to my talk. As I was putting this talk together a couple of weeks ago, I was sitting in my office, door open, and Steve Boyer wanders into my office, starts looking on my shoulder. He does this all the time. Steve Boyer, you probably don't know him, but he's a kind of our group salesman. He's the guy who goes out to our customers and shows them our great technology and just puts on a wonderful show. I wish he were here today, but you would really be impressed if he was. He can really do a song and dance that'll knock your socks off. So anyway, he looks over my shoulder and he says, "What are you doing?" I said, "Well, I'm putting together this talk that kind of explains the work I've been doing for the last 10 years and, kind of makes a really good story about the whole thing in one hour presentation." And so I said, "That is the most boring presentation I've ever seen. Are you sure you want to give that?" So, it doesn't have quite the impact that most of Steve's talks do. If he were up here, he'd be showing you whiz-bang graphics and all sorts of pretty pictures and stuff. My slides are not like that.
I want to intervene here now. So, I actually have seen 2 or 3 talks from the group that Scott is in before I selected Scott because everybody told me he's the most technically inclined of this group at IBM Research, and so he's going to give you the real meat instead of all the flash.
Well, let's hope so. I hope you find something of use in here. I was going to say that while Steve's talk may be flashier, if you ask him some questions, he may give you answers that make sense to him, but I'm not sure they're actually reality. So keep that in mind. I think everything I'll tell you here is definitely grounded in reality. And Paul interrupted me just now. That's great. If you guys have comments, questions, thoughts you want to interpose, I love that. Most of the talks we give at Almaden are extremely interactive. People are not afraid to jump up and tell you what they think, even if it totally disagrees with what you're saying. So don't hesitate. I've got this little thing I need to start using. So I'm going to back up a little bit. Instead of talking about sensing the information space, I'm actually going to talk a little bit first about what I call exploratory analytics. It's really kind of what I realized that I do now. I didn't start out knowing I was going to do exploratory analytics for a living 10 years ago, but it turns out that's what I do. And I think it's a little different than maybe your typical data mining approach. And so I want to try to give you a flavor for what that means. And in doing so, I'm going to describe what I call practice of exploratory analytics, and really go over kind of a broad view of 10 years of work in this area and how it's impacted IBM. And then I'll start talking about this idea of a process. How do you actually do exploratory analytics in practice in a way that most of the time will get you something useful in the end that will actually have an impact on the business. It's not the kind of process that you do step by step by step, and at the end you get this result. It's more of a set of ways of doing things that allow you to get the most value for the time you put into your data. And the meat of the talk will be on this corporate brand reputation analysis. It's One of the applications we did in the space, I think we started working on it in 2006. It kind of, in the last couple of years, it was rolled out to global services in IBM. It's become a very successful application in the idea of analyzing social media. And I think it's a really good exemplar of the kind of stuff we do in this area. Then finally, I'll kind of give you some of my thoughts of where I think exploratory analytics is going in the next several years, the things we're really working on hard right now, and give you some thoughts about where it's all headed. And then the very last slide just kind of gives you pointers to the book, pointers to lots of papers we've written, and hopefully gives you some place to continue looking at this area. So this actually comes from Wikipedia, a great place to kind of get a feel for research out there in the general area. And actually I didn't know about this EDA until just I started putting together this talk and looking around at what people had done. And it turns out this is actually 30 or 40 years old, this idea. Came out of statistics. If you've been in data mining a while, you realize almost everything we've done is actually done many, many years ago in the statistical field. This is no exception. A guy named John Tukey created this idea of exploring as opposed to confirming. And whereas all the approaches and tools he saw out there people were using were all in the confirmatory area, what he realized he was doing was very different. It was more figuring out what are the hypotheses that you want to be able to test, not in terms of formulating those hypotheses as opposed to actually confirming those hypotheses. I think that's a really useful concept and one that I think applies exactly to the work that I do. Less formally, I think it's essentially the process of analyzing data to learn what you don't know to ask. You know, a typical statistician will have a certain set of questions. He's going to ask those questions, get some data, answers those questions, and see whether his theory is proven or disproven by the data analytics. Exploratory analytics is totally different, that you don't necessarily have any questions. What you have is a lot of data. You're trying to understand what that data is telling you to ask. This is actually, again, this is from John Tukey. I thought this was really surprising and also very true. If we need a short suggestion of what exploratory data analysis is, it's these things. It's an attitude, it's a flexibility, and it's graph paper and transparencies. And some of you, this is kind of a mixture of ages. Some of you may not know what transparencies are, so I'll explain that. I lived through this age. You actually had to give a presentation. Computers didn't connect to the projectors like they do now, and so you had to actually print your slides on these transparent films that you would put on overhead projectors. So that's what he's talking about. And what he's really trying to say with that is you need a way to communicate via graphics what's going on with the data, because it's not something you can understand through a test or through a table or through a number. It's something that the human mind, the way it works to discover these things, has got to see them. And so it needs a way to display the data and communicate it to other people so that they can understand it and contribute their thoughts to the process. So the picture examining eye is the best finder we have for the wholly unanticipated. It's exactly the way I feel about things. So how does this compare to what you're probably used to seeing? The confirmatory analysis, I think, is what most people do. And I think in your daily practice, if this is the kind of data mining you do, these things will seem like very familiar touch points. Obviously, the more data you have, the better. Why? Because you have something you're trying to prove, and if you just find that data that proves it, you're done. So get more data. I mean, that's got to be good, right? Predefined annotations. By that I mean you've got a set of patterns. You want to have those defined ahead of time so you can just throw all your data right at them, have those annotations work, and then be fire off whenever they see the right data. That's just very efficient. It's sure to work. And again, the more data the better, and you can really make it optimized and very fast. Batch processing, again, it's like you figure out what you're going to look for. You got your data over here, throw it at the thing that's looking for that stuff, and at the end you'll get your answer, all done. Nothing could be simpler. Supervised learning, the idea of ground truth is very important to this idea because obviously you're confirming something you already know, so you've got some examples of that in your head or on paper. You found those examples. You can now build a model around them and then find all the other things in the universe that match that idea. And again, you're certain of finding it. There's a lot of certainty built into these approaches. It's very comforting. Typically, it's a single hierarchical approach. What I mean by that is you start with this view of here's everything, and then here's 10 different ontologies that I can, or 10 different classes that I can break things into. Within each of those 10 classes, there are subclasses, and there's really just this one kind of overall ontology that describes the whole universe, and I can make all my data fit into that, and then everything will be classified appropriately. There's only one of those, however. It's kind of like the world has to all kind of fit into that way of thinking. And precision and recall is a great way of kind of evaluating your approach. You have these things that are right, and you have things that are wrong, and you have things that are true positives and false negatives, true negatives, and you can go ahead and evaluate every single approach and decide which one is the best approach. And there's always one that's better than all the others, and you can identify it and go forward from there. That's what we're all very familiar with. We see it all the time in data mining conferences. So what's exploratory and how is it different? Well, first of all, more data isn't always better in exploratory. In fact, more data is typically a problem. What you want is data that's relevant to the universe you're trying to study. Anything that goes beyond that universe is going to be noise instead of signal, and it's going to confuse all the things you're trying to understand.